Hey, so this is significant figures part 2. In the first one of significant figures of my third video, I only explained how many significant figures are there in a single number. Now let's look at how many significant figures should be in your final answer when you're adding, subtracting, dividing, or multiplying. Now for adding and subtracting in significant figures, let's just say for significant figures, the rule is the same for both of them. So the rule is when you're adding or subtracting, your answer can only show as many decimal places as the measurement having the fewest number of decimal places. So let's look at this for example. 5.00 plus 4.00 would give you 9.00. Now, let's look at the rule again. When adding or subtracting, your answer could only show as many decimal places as the measurement having the fewest number of decimal places. So there is really no fewest decimal places. They're both the same. And the decimal places for here would be 2. So this decimal place would be 2 also. So 5 plus 5.00 plus 4.00 would give you 9.00. Now let's look at another one with different significant figures. You have 5.95 plus 4.0. Now the answer originally would be 9.95. Now let's look at the rule. Let's change our answer referring to the rule. When adding or subtracting, your answer can only your answer could only show as many decimal places as the measurement having the fewest number of decimal places. So if you look here, 5.95 has 2 decimal places and 4.0 has 1 decimal places. So what do? You round up until you have 1 decimal places. So you look at, so this is 1 decimal places, meaning it's the 10th. So you would round your final answers to the nearest 10th. So 9.95, there's a 5 here, so you would round the 9 up by 1, and your final answer you should get is 10.0. Since you have a 10th decimal place here, you should have a 10th decimal place in your answer. Okay, now let's do an example for subtraction. I used the same numbers for both problems. So 5.00 subtract 4.00. There is no fewest number of decimal places. They're both the same. So you could just write out 9.00, the same number of decimal places as both numbers that you use for your subtraction. Then you have 5.95 subtract 4.0. Again, the fewest number of decimal places, but let's do the math first. You have 1.95 and refer back to the rule. Your answer can only show as many decimal places as the measurement having the fewest number of decimal places, and you have 1 decimal place here and you have 2 decimal places here, so you want to look at this one. This 1 decimal place is to the 10th, so you should round your final answers to the 10th, and you should get 2.0. And that's your final answer for subtraction. Now let's look at problems with multiplication and division in sig figs. Okay, the rule for multiplication and division are both the same, and the rule is the least amount of sig figs you have used in the equation is the total amount of sig figs in your final answer. So let's go over what I mean. Say you have 5.009 times 2.00, and your answer would be, well, really your answer would be without changing sig figs or anything, and yeah, so your answer would be 10.018. Now let's refer back to the rule. The least amount of sig figs you have used in the equation. So let's look at the least number. You have 4 sig figs here in 5.009, and you have 3 sig figs here in 2.00. So let's look at the other half of the rule. Is the total amount of sig figs in your final answer. So since you have used 3 sig figs here and it's the lowest amount in this equation, your answer should be in 3 sig figs. So you look at the last sig fig, which is 0, and then you look at the number after it, which is 1. You would try seeing if you could round it up, but it's not greater than 5, so you cancel it out, and your answer is in 3 sig figs. Now let's look over another problem. You have 4.0000000 times 5.00. Now your answer for this should be 20.0000000. This is 00 because of those two zeros. Now let's look at what it says. The least amount of sig figs you have used in the equation is the total amount of sig figs in your final answer. So you have 7 sig figs here because trailing off zeros are counted as sig figs. You have 3 sig figs here because these two zeros are trailing off. So this 3 sig figs is the lowest amount of sig figs you have in this equation. So your final answer should be in sig figs. So let's count out 3 sig figs. You got 2 as 1, you got 0 as 2, and you got another 0 after the decimal. Since it's trailing, the 0 in between the 2 and the trailing 0 becomes a significant figure. So it's 20.0. 20.0. And that's your final answer in sig figs. And that's all for my video. Hope this helps you. This is part 2. Part 1 would be my third video. It just says significant figures. So if you want to learn how many significant figures are in a single number, you would go to video 3. And if you want to learn how to use significant figures during addition, multiplication, division, well, you're looking at it. This is the video for you. Hope you learned something for it. Thank you and goodbye.